In the Hinderer studies, researchers tested 16 10-month-old babies. The population is all 10-month-old babies. The sample is the 16 10-month-old babies that were tested. Answering the question about whether the sample is representative is more difficult, since this problem did not describe how the babies were selected. The best way to have selected the babies would have been to use some random technique in which all 10-month-old babies are equally likely to have been chosen. However, it is more likely that they chose the babies using an advertisement at a hospital or a Mother's Day Out program or a school. That would make the sample include only babies whose parents were likely to have seen the advertisement, and therefore the sample is likely to be non-representative. The study is not useless, however. We can generalize the results to the population of babies that are similar to our sample. And the study can lead to other studies with other populations. Let's consider the facts that we want to know about the population. In this example, we want to know about the distribution of genders. We might want to calculate the percentage of the population that is male. This would yield a number, p, that represents the proportion or percentage of the population that is male. A number that describes the population in this way is called a parameter. Of course, unless we have the resources to take a census, the value of the parameter is unknown. Instead, we will calculate the percentage of the sample that is male. We'll call this value p hat. We give it a hat to distinguish it from the population parameter p. A number that describes the sample is called a statistic. If the sample is representative, we expect the value of the statistic to be close in some sense to the value of the parameter, which is unknown. In this example, we were looking at the gender of the study participants. This is an example of categorical data. That is, we are looking at characteristics of our study participants that are described with a word or category rather than with a number. Commute time in minutes is an example of numerical data. In this case, instead of being interested in the proportion of the population that fits some characteristic, we are interested in an average value. In this case, the average commute time. The average commute time for the whole population would be a population parameter called the population mean. We use the Greek letter mu to represent the population mean. Again, the population parameter is unknown, so we gather data about the sample and calculate the sample mean instead. The notation for the sample mean is x bar. Notice that we have recorded the commute time using minutes and fractions of minutes. Time is a continuous variable. Depending on what measurement tool we use to measure it, we can get any number of decimal places beyond the decimal point. An example of numerical data that is not continuous is the number of siblings each participant has. It is not possible to have fractional siblings, so this is not a continuous data type. We call this type of data discrete data. For discrete data, the set of all possible outcomes can be listed. However, we are still interested in averages, so we call the population parameter the mean and use the symbol mu. And we call the sample statistic the sample mean and use the symbol x bar, as we did with the other type of numerical data. This table summarizes the notation for the concepts of parameter, statistic, and the data types. For the categorical data, the most often used parameter is the population proportion in some category, and the corresponding statistic is p hat, the sample proportion. For numerical data, whether it is continuous or discrete, the most often used parameter is mu, the population mean, and its corresponding statistic is x bar, the sample mean. This table is not exhaustive. There are other parameters and other statistics that a researcher might be interested in. For example, median, maximum, standard deviation, or range. In the Helper-Hinderer study, researchers tested 16 babies to see if they preferred a toy that was helpful to other toys over one that was not helpful. For each baby, they recorded which toy the baby chose first. Please answer the questions below, then click to continue.